This video will teach you Go or Golang in a single project. It's designed for those of you that want to learn the language quickly without having to go through countless videos, courses, or long documentation. This is going to cover all of the basic and even intermediate features of Go, as we're going to work on a sufficiently complicated project which is going to teach you a lot about the language and give you really a core understanding that will allow you the confidence to go and write your own Go code. Now, with that in mind, this video is not designed for complete beginners. As much as you can follow along, this is really designed for those of you that have some experience programming and want to quickly pick up the Go language. If you already know about things like if statements, for loops, and functions, this video is going to be a lot easier to follow along with, and you're going to really quickly pick up the differences in Go compared to other languages because we'll immediately be applying it into a project. Anyways, with that in mind, let me discuss the project we will create, then we'll hop into the code editor and start coding. Now we're going to be working on a slot machine. Now I love the slot machine project because it's complicated enough that we can build it in about an hour, and it covers a lot of the different features of Go. But with that in mind, it's also not too insane where we have to go into a ton of complexity and you can kind of learn more about the specifics of a slot machine. And it's also something that I just find kind of interesting and fun. Now, if you're unfamiliar with how a slot machine works, we're going to build a simplified version here. But the basic idea is that we have some different reels. The reels are kind of like columns. Now, in those columns, we're going to have some different symbols. Each of these symbols has a particular value. For example, maybe you have a jack, that's low value. You have a queen, that's higher value. You have a king, that's even higher value. And an ace is the highest value. Now, what we're looking to do is get lines of these symbols across the columns. So if I have 3 columns, we're going to look in the rows. And if we see symbols matching up in something like a horizontal line, that means we've got one line and we're going to win some multiple of our bet. So if we bet $10, for example, and we get a line of aces, the line of aces might pay 10 times our bet, so we would get $100. Okay, so the better the symbol, the more that we win. And again, we're looking in those horizontal lines. This will make more sense as we code it out, but I just want to give you a bit of context because I know a lot of people are confused with slot machines, and that's actually good because that means you probably don't gamble, which of course we do not support on this channel. This is purely for fun. It's not real money. Definitely don't gamble. In fact, just build your own slot machines in Go like we're going to do here. Now, with that in mind, I do want to share with you a great tool that we're going to utilize in this video, which is GoLand, a JetBrains IDE. Now, this is an IDE that's built specifically for Go developers, and it's what we'll be using in this video, courtesy of the sponsor of this video, JetBrains. Now, GoLand also supports other languages like JavaScript, Python, Docker, Kubernetes, Terraform, and more. So if you're working with a mix of technologies, then it's got you covered. Now, one of my favorite things about GoLand is the AI-powered code completion, which works entirely locally so your data never leaves your machine. It makes coding so much smoother, like having an assistant that knows exactly what you need next. Plus, the IDE is very customizable with tons of verified plugins, so you can tailor it to fit how you like to work. Now, if you want to follow along with me and use the GoLand IDE, then you can get 6 months for free by using the code TechWithTim at the link in the description. Definitely check it out if you're serious about leveling up your Go projects and take advantage of those 6 months for free. So at this point, you're either going to use something like GoLand, which you can get at the link in the description, or some other editor or IDE. Doesn't matter, either way, just open up your editor and open a new folder. From that new folder, that's where we're going to start writing code, so let's get into it. All right, so I'm in my editor here, and you can see that I've got open a new folder, which is right here. Now, what I'm going to do is just make a new file inside of this folder. So I'm going to go new and then go file, and I'm going to call this main.go. This is where we're going to be writing a majority of our code, and then later we'll split it up into multiple files. Now, you'll notice that the first thing we see inside of this file is this package line. Now, by default, it can be equal to the name of the folder that you're inside of, but usually what I like to go with is just call this package main. Now, we can discuss the packages later on, but you want to make sure all of your Go files have the same package so that they can import each other and they can kind of work together, which you're going to see later. Anyways, we're going to go with package main as our first line. Now, obviously, before we can actually run any Go code, we do need to have Go installed on our system. So if you don't already have Go installed, go to this link, I'll leave it in the description, run the installer, and it should automatically install Go for you and add Go to your system path. From there, you can use the Go command. So if you want to verify if this installation is working, just open up your terminal and simply type Go. If you type go, you should get some kind of output here. And if you're getting that output, this means this is installed and it's good to go. Now, no pun intended there, good to go with the Go language. Okay, so first thing we do within our Go file here is we write the entry point function. Now, different from something like Python, for example, which I mostly code in on this channel, if you want to actually be able to run any code here, you need to have a function called main. So what we're going to do is define a function. We're going to say function main. We're going to put a set of parentheses and then a set of braces. Now, this will be the entry point. This will run automatically when you run your Go file, and anything you put inside of here will be executed. So what we want to do probably is print out something like hello world just to get started. So what we're going to do is import the FMT package. Okay, this stands for format, and make sure you import it exactly like this. Now you'll notice if you're using something like GoLand or you have some support for kind of linting in Go, what you're going to notice is that you get this red underline. Now it's telling you that this is unused. And in Go, unlike a lot of other languages, you can't actually have any unused variables or any unused imports. If I were to actually try to compile this code right now, which I'll show you in a second, it would give me an error. So in order to use this import, we need to actually write fmt dot, and then we have a bunch of different options. Now for now, we're just going to go with print line and then hello world. Okay, so this is how you print something out in Go. You say FMT, which stands for format, dot print line, and then you put a string in here, which is surrounded with double quotation marks. Okay, so now we have a functioning Go program, and the next thing is to learn how to run our code. Now to run the Go code, we're going to open up our terminal. This can be any terminal you want on any operating system, doesn't matter. And we have two options. We can directly run this where it's going to be compiled and then automatically ran for us, or we can build a compiled version and then manually run that compilation. Now, what I mean by that is that Go is slightly different than other languages like Python. Before you can run it, we actually need to take what's called our source code and compile this into something that's executable. Now, if you're on Windows like I am, it's going to give you a .exe file. If you're on something like Linux or Mac, then you should get something like a .sh file or some other executable file. This means that even if someone doesn't have Go installed on their system, they're able to run the Go code that you're writing as long as you give them the compiled binary or the compiled file. So what I'm going to show you how to do is compile it, and then I'll show you how we run it after. So what we're going to do is in the same directory where our Go file is, you can see I'm in Go tutorial, we're going to type go build and then the name of our Go file, which is main.go. Now the build command is simply going to build the executable file for you, and you should see that in your directory you get some file with the same name as your Go file, and then either a .exe or something like a .sh. Now that we have this, we can directly execute this file. And on Windows, to do that, you can just type the name of the exe, or I think I need to do / and then the name of the exe, and it will run it. And I believe that's the same command on Linux and Mac as well. So you can see I did / main.exe that then executed the executable, which is hello world. And again, I can now take this exe, send it to anyone I want, and they can execute it on their computer without having Go installed, because this is compiled and it can be ran by your operating system. But of course, the exe is not going to work on a different operating system. It only works on Windows, and same with your .sh files. Great. So that's how you compile it, but sometimes we don't want to have kind of these two steps where we compile it and then we run it. We just want to directly run the code. So to directly run the code, you can just type go run and then the name of your file, which is main.go. And when you do this, it's going to compile it for you automatically and then run it, and then it will remove the compiled file after. So it's kind of just keeping it in memory while it's running this code. So you can see we now have hello world and no new file was created. I can delete the main.exe. So if we delete this and go here, you'll see that it ran it, and now we don't have the exe file popping up here. Okay, so you can build or you can run. For this tutorial, we're mostly just going to use go run because that's a little bit simpler. Okay, so let's clear the screen, close the terminal, and get back to doing some coding. So you've seen already that we have fmt.println. This will print a new line character after we print the string, and we also have a few other options within the format package. So for example, we have printf. Now printf stands for format, and what we can do is print a string with different formatting codes. So for example, I could do hello %s, And then after this, I could put another string, say like Tim. And what's going to happen now is Tim is going to match up with the %s. %s stands for string. And this means, hey, I want to take this string here and I want to print it as a string within this formatted string. But when you use printf, it's not going to print a new line character afterwards. So to kind of quickly show this to you, let's just print this out twice. Let's go to our terminal and type go run and then main.go. And you're going to see that what will happen is this will appear on the same line. The reason for that is with printf, it doesn't automatically print the new line character. So if I want to go to the next line, I need to manually print that at the end of printf. This is actually an advantage as it gives you more control, but just something worth noting if you're going to use that. So these are kind of the two main functions you're going to use a lot when you're outputting to the terminal, printf and println. Okay, perfect. Now what we want to do though is we probably want to start our program, which again is kind of going to be the slot machine here, by asking the user for their name. So I'm going to write a new function that will ask the user for their name. Once we have their name, we can then welcome them, and then we'll start setting up some other things like collecting the user's bet, because they're going to bet every spin on the slot machine, and then seeing if they win, etc. Okay, so let's make a new function with func, and let's call this getName. Okay, now when you define a function, it looks just like this, and we're going to use camel case by default in Go. Okay, now I'm going to define a variable which will store the name. In Go, we have a few ways to define a variable, but this is one. Now, this is going to use what's known as kind of the quick assignment or the implicit assignment operator. This kind of looks like a walrus, right? It's the colon and the equal sign. And what this will do is define a variable where its type is implied based on the value that you put on the right side. That's just fancy words for saying, hey, if you put a string on the right side, the type of this variable will be a string. If you put an int, like 4 here or 45, then the type of this variable will be an int. And that's where we can get into data types in Go. So this is the most common way to define variables, but if you want to explicitly define the type, you can do something like this. Var name, and then string, and you don't actually have to give this a value. You can just define the variable like this, or you can assign it something directly like hello. Okay, so here we've now just defined a variable name. Its type is string, and we've assigned it the value hello. But if we wanted it just to be the default value, we could just do it like this. And now we have a variable allocated called name, whose type is string, but we haven't yet given it a value. So its value by default will be whatever kind of the starting or default value of this type is, which is just an empty string. Okay, now the reason it's highlighting in red here is because I haven't used it. As I said in Go, we need to actually use all of our variables. So if I want to use this, I can say fmt.printf, and then I can just print, for example, a formatting code like %s, and then name, and then we would be printing out the name, and now we're not going to get that red text. Okay, so this is how you define a variable. We have the string type. We also have the int type. This by default is going to be an int 64, but in Go, you actually have the ability to define the number of bits that you want to use for types like this. So I can actually specify that I want to have an int 8. I want to have an int 64. I want to have an int 100, or actually 64, I believe is the max, sorry. Have an int 32, an int 16. You can do that. That's valid in Go. We also have the ability to use an unsigned integer. So if I say uint, for example, this defaults to a uint 64, meaning we're using 64 bits. And this means we can only store positive or 0 values. So I can't store a, for example, -9 here. If I do that, that's actually an error, even though it's not showing it right now. And we're not going to actually store -9. It will store kind of a weird derivative of this. Okay, now I also can do uint 8. I can do uint 16. And then if we want to have floating point values, for example, we have two types. We can use float 32 or float 64. Okay, other types that we can use, for example, we have a Boolean, which is defined as bool. Now this will be equal to a lowercase true or a lowercase false. And then of course we have other types as well. For example, we have this byte type, which is equivalent to the int 8, or sorry, uint 8. We also have other types like a rune type, which is equivalent to an int 32. I'm not going to get into all these custom Go types, but I'm just showing you a few ones that we have here. If you want to make something like an array, you put a set of square brackets, and then you put the type, and this is defining that we're going to have actually what's called a slice in Go, which we're going to talk about later, of strings. Apologize if I'm going fast, but I am trying to, not kind of lag on all these topics because I know a lot of you already know how to code. Okay, so we are going to define our variable using this implicit syntax. So when I say name colon equals string, this is still a strongly typed variable because Go is a statically typed language, meaning that if I wanted to later on, I can't change this to something like an int. This is invalid because now name has been defined as a string type. And if I do this, if I hover over it, it says, hey, you cannot convert or put this 8 here in this string type because they're not the same type. Okay, so unlike Python, JavaScript, something that is dynamically typed, you have to have the same type or hold the same type within different variables that you define, which is one of the advantages of using Go. Okay, so we have name is equal to a string. We can print out the name, but of course we want to collect the name from the user. Now, in order to do that, let's first just start with a few kind of nice messages here. So I'm going to say fmt.println, welcome to Tim's Casino, ... Okay. And then we're going to say fmt.printf this time, and I'm going to say enter your name, and then a colon, and a space. And notice I'm not adding the new line character because I want to start collecting input after this line. Now, if I want to collect input, what I can do is the following. I can say underscore comma ERR is colon equal to, and you can see the AI feature is actually filling it in for me, and it's this fmt.scanline ampersand name. Now, what this is doing here is this is going to scan the entire line for any input that I enter. And whatever I enter, it's going to assign that to the name variable. Now, this ampersand that you see here is actually giving me what's known as the reference to this variable right here, which means that I can actually directly change the value of this without creating a new variable. Now, you may not have seen this before if you've worked in a language like Python, for example, but in Go, if you just use the name of the variable like this, what you're doing is you're just referring to the value here. You're not referring to the actual container that's storing the value. And if I were to do something like name here, this wouldn't actually be able to change the value of name. Now, when I put this ampersand here, what this is saying is that I'm going to get the pointer or the reference to the variable name, which means I'm not just getting the value, I'm actually getting kind of the box in memory where this value is stored, and then I can change what's stored inside of that because I have access to that. If you've ever worked in other languages where you're familiar with pointers and references, that's exactly what this is doing, okay? It's getting kind of the pointer to this here, so we actually know where in memory this is stored, and then we can assign whatever's typed in here to this variable and actually change its value. Okay, again, I know it's different from languages like Python, for example, but that's what's happening. Now you see I have an underscore and I have ERR. Now, rather than using something like a try catch in Go, what we actually can do is get errors directly from the return of a function. So here I'm saying, okay, I want to call this function, and then the first thing that's returned, I don't care about it, so I put an underscore, and then the second thing is an error. So if an error occurs, I can actually handle that by looking at this error variable. The way you do this is the following. You can say if, and then error does not equal nil, and then you can handle the error inside of here. Now, nil is kind of the none type in Go. So what I'm checking here is, all right, if there was some kind of error, so if it's not equal to nil, then I've got to do something. So here, I'm just going to return an empty string. Okay, that's it. Next, I'm going to say fmt.printf, and I'm going to say welcome, and then %s, and then I'm going to say let's play like that, and then I will print a \n, and I will put the user's name. Then I'm going to return the name. Now you'll see here that in my return statements, I'm getting an error. And the reason for this is that in Go, you need to explicitly define the return type from functions. So what I need to do here is I need to actually write string, and I need to indicate that this function here returns a string. Okay, so that's what you can do. I'm saying I want to return some string, so I'm going to write that here, and now this return statement is valid. And actually, if I didn't have the return, if I commented it out using 2 slashes, like you can see, we would actually get an error here in the function. It would tell me, hey, you need to return something. And you can see actually if I highlight over this, it says missing the return statement at the end of the function, because since I'm returning something, well, I must return a string. Okay, perfect. So that's it for getting the name. Now, if we want to use the getName function, we can use it from down here. So I can say name, : and then getName. Now notice that you use the colon equal to whenever you're defining a new variable that does not yet already exist. If it already exists, I don't need to use that. I can just change the value using name, or I can reference this variable. Okay, now I need to use name because, again, we can't have any unnamed variables or unused variables. So if I don't care about the return, which I don't right now, I can just call the getName function and not store it anywhere. Or I could do like underscore is equal to this, but that doesn't really make too much sense. We can just remove the variable. Okay, I know this is a lot, but at the beginning, obviously, there's a lot to go over, and then we can start moving faster. Okay, so now let's run the code and just test this. So I'm going to say go run and then main.go. And I'm going to enter my name of Tim. It says, welcome, Tim. Let's play. Okay, there we go. We now have a function that collects the user's name. Okay, that's it. Next thing we're going to do here is we're going to start handling kind of getting the bet from the user. So what we want to do is have some kind of balance. Maybe the user is going to start with $100, $200, and we're going to ask them at every spin of the slot machine, how much do you want to bet? Do you want to bet $10, $20? If you've ever been in a casino or used a slot machine, you know that you're placing a certain amount of money kind of as your bet before you spin the wheel. So we're going to go in our main function here, and we can go before we get our name, doesn't really matter. And we can define a variable called balance. So I'm going to say balance is colon equal to, and then 200. So we'll start the user with $200. Now what we're going to do is write some logic that will kind of ask the user for their bet. So how should we do this? Let's make a new function, and let's call this getBet. Okay, but in order to get our bet, we need to know how much money we have so the user can't bet more than they have. So what we're going to do is take in a parameter called balance, and we need to define that this parameter here is going to be a uint, or an unsigned integer. Okay, then we can say that this is going to return an unsigned integer, which is fine, like that. Okay, now I'm saying uint because we know this is going to be a positive value or a 0 value. Okay, so from getBet, similar to before, we need to ask the user how much they want to bet. And we need to make sure they give us a valid value. So I'm going to say var bet, and I'm going to define this as a uint. Okay, and then I'm going to make a while loop. I'm essentially going to keep asking the user to enter a bet until they give me something valid. Now in Go, we don't have the while loop syntax, but we do have this for loop syntax. So I can actually say for, and then true, and this is equivalent to a while loop. Okay, so same thing. I put my condition here, and then I write my for loop. So I'm saying, or I write my while loop, whatever you want to call it, but we're just using for because that's how it works in Go. So we say for true, and then what we're going to do is ask the user to enter their bet. So we'll say fmt.printf, enter your bet. And then what we're actually going to do is tell them what their current balance is. So I'm going to say balance is equal to, and then I'm going to say with a $, %d, like that. And then I'm going to do a colon. Okay, perfect. Now what I'm doing here is actually just inserting a numeric value. So now I can just put balance here, and %d stands for digit, or kind of like whole integer. So I'm going to take whatever the balance is, and I'm just going to embed that directly inside here as their balance. Okay, so enter your bet. And I'm also going to do one more thing, or 0 to quit. So the idea is we're going to allow the user to leave if they type in 0. Okay, so we're going to ask them to enter their bet, and now we need to get their bet. So to get their bet, we can say fmt.scan, and this time I'm not going to do scan line, I'm just going to do @scan, and I'm going to do &bet. Okay, now what this is going to do is it's going to look for a valid number, and it's going to assign that into here, this uint variable. Now, if this gives us an error, we're actually not going to handle that for right now because it's a little bit complicated with getting user input in Go. So we just need to kind of assume the user is going to give us a number. The number could be too big, that's fine, we can handle that. But if they give us something like a string, then this code is going to break. It's not going to work properly. So just keep that in mind. There is more advanced ways to handle the user input, but I don't want to get too complex right now, especially because we're just starting. Okay, so let's imagine we get a valid number here, and we're going to take whatever that number is, and we're going to assign that to this bet variable. Now what I can do is I can check if their bet is valid. So I'm going to say if the bet is greater than balance. Notice that when I do an if statement, I don't need to do the set of parentheses. I can just write directly the if statement, and then I can put a set of braces here and put inside what I want to happen if this is true. So I'm going to say if this is the case, I'm going to say fmt.println, and I'm going to print bet cannot be larger than balance. Okay. And then we're going to have an else statement. And in the else, we're going to say break. Now we need the break so that we can break out of the while loop. Perfect. Now, if we break, that means we have a valid bet. So we can go here and say return bet. Of course, when we return something, that's going to go back to the caller of the function. Okay, so we have get bet. We are going through. We have our while loop happening here. We're scanning this. It's going to give us a warning saying that we have an unhandled error. That's because this can tell us if there's an error. But again, we're not going to handle that for right now. And now we want to use this get bet function. So what I'm going to do is say get bet, and I'm going to try to get the bet and then pass my balance. Okay, but notice when I do this, that it's actually giving me a red squiggly, and it's saying cannot use balance type int as type uint. The reason for this is that when we write this implicit assignment here, whenever we put some kind of number, this is going to be implied that it's an int. Okay, so the default type for all of the numbers we use in Go is just int. So it's saying that I can't use this type int because balance is a variable of type int as a uint in this function call. So how do I handle that? Well, there's two things I can do. I can just kind of explicitly define this. So I can say var balance uint is equal to 200, and now this works. Or I can actually cast this int to a uint, which is what I'm going to show you here. So I can just simply say uint and then put 200 here. When I do that, I'm explicitly saying, hey, I actually want this to be a uint type, and now the type of my balance variable will be uint. Okay, so this is how you can do a type conversion, at least between numbers that are valid to do this for. All right, now for the bet, I'm just going to say bet is colon equal to get bet, and I'm going to put that down here. And then just so that it's not unused, I'm going to say fmt.println, and we'll just print out the user's bet. Okay, so now what we're doing is we're asking them for the name, we get the name, we ask them for the bet, and then we print out the bet. So let's go ahead and run our code, bring open our terminal and type go run. It says welcome, enter your name of Tim. It says welcome Tim, let's play, enter your bet or 0 to quit. Let's enter 201, it says it cannot be larger. Let's enter 175, and then it prints out 175. Amazing. Okay, so now we have the user's name and we have their bet, but what we need to do now is kind of keep asking them to bet until they type in 0, and then we can quit. Now we of course are going to spin the wheel and deal with all of that, but I want to handle kind of the main logic first. So we set the balance, we get the name, and now what we're going to do is say while, or not while, I keep doing that. We're going to say while balance is greater than or equal, or actually we'll say greater than 0. Then we're going to do this. Okay, so what's going to happen is we're going to say enter your bet, and then we're going to subtract the bet from the balance. So we're going to say balance minus equals bet. So as soon as they bet something, we're going to remove that from the balance. This is fine because the balance is uint, and what's returned from the bet is a uint. So this conversion or this arithmetic is fine. And then we can kind of just keep going. And we also need to do something else. We need to say if the bet is 0, so if bet is equal to 0, then we need to break out of this for loop, because remember we said here that if you enter 0, you're going to quit. Okay, then we're going to go down here and we're going to say fmt.println, and we'll just say you left with, and actually we're going to change this to printf because I want to put a variable in here, and we're going to say percent or $, if we can do $%d, and then \n, and then a period, and then we're going to put the balance. So we're going to tell the user how much money they left the slot machine with, because either they left with 0 if we got out because we broke from the for loop because the balance was equal to 0 or less than 0. Otherwise, if they typed in 0, that means, hey, they no longer want to bet anymore. So we'll just tell them how much they had when they left. Okay, so let's quickly test this logic before we go any further. So let's run this. We're going to say Tim, let's type in maybe 34, and then let's type 0, and it says you left with $166. Amazing. I also realized I need to put the period before the \n, and now we are able to get the bet and get the name. And I'm going to minimize these now, and we're going to start getting into some of the more complex logic and handling kind of setting up the wheel or the reels, whatever you want to call it, and spinning the slot machine. All right, so what I'm going to do now is I'm going to start defining a few values that we're going to need when we start setting up these reels. Now, the idea is this. We're going to have some kind of symbols, right? Like the following. Okay, you can name these symbols anything that you want, but we're probably just going to use the letters like A, B, C, and D. Now we can say the A symbol is maybe the best and it's the most rare, B is the second best, C is the third best, and D is the worst. What we're going to do is set up a grid that looks like this. So really a two-dimensional array. We're going to have array inside of another array and kind of rows of symbols. Now what I need to do here is I need to kind of randomly generate some kind of grid that looks like this based on the symbols that we have and the size of the grid. So it might be a bit confusing again if you've never used a slot machine before, but the idea with a slot machine is like we have these long reels or columns. So maybe one of the reels looks something like this, right? It's just like long reel. And the idea is that we spin the reel and we end up only seeing, for example, 3 of the different items that are in that reel or in that column. So what we need to define in order to set this up is, first of all, how many symbols of each type we have in any given reel. And then we can randomly pick some of those symbols to display in the display the user actually sees. I know it's a little bit complex to understand, but the point is like we're only going to show maybe this up here, right? Like this is the portion that you actually see. But the idea behind the scenes, at least what they want you to think when you're spinning this, is that there's a bunch of symbols in this column, and when you're spinning it, you're just randomly getting a few of those symbols popping up in each and every column. So we need to define, okay, how many of each symbol do we have in any given column? And then we need to randomly display those symbols in the viewable area to the user, okay? So what we're going to do for that, first of all, is we're going to define how many of each symbol we have. And obviously, the fewer of a symbol that we have in the reel, the more rare it is for it to appear. So we're going to say symbols is equal to, and we're going to create a map. This is kind of like a dictionary or like a hash table if you've seen it in other languages. So I'm going to say map. And then the first thing we do inside a set of square brackets is we define the type of the key in our map. So I'm going to say that the type of my key is a string because that's what's going to store our symbols. And then we're going to have, we can actually make this a uint, and the uint is going to be the value. Okay. So we're saying we're going to have some kind of symbol or string, and then we're going to have the count or the frequency of that symbol, and that type's going to be a uint. So what I'm going to do inside of the map, because I'm using a set of square brackets here to define one, and we need to make this a colon equals 2, is I'm going to say A is associated with, for example, 4. Okay, then I'm going to say B is associated with, for example, 7. And then C is equal to maybe 12. And D is equal to maybe 20. Okay, so what I'm doing here is I'm defining that I want to have the symbol A appear 4 times in every single column or reel. B will appear 7 times, C will appear 12 times, D will appear 20 times, and I'm kind of setting the odds for these symbols to potentially show up. So since we're going to say A is the most rare symbol that we have, we're making it show up the fewest amount of times, right? And then same with B, C, D as we go up here. Okay, so that's kind of the number of symbols that will be in each column. And then based on this frequency, we'll kind of randomly pick symbols to display. Now, as well as the symbols, we also need the multipliers. Now, the multipliers is going to be how much is each symbol worth if we get a line of it. So I'm going to do the same thing. I'm going to say string associated with uint, but this time I'm going to define how much I'll multiply the user's bet by if they get a line of these symbols. So we're going to say A is 20, which means you'll get 20 times your bet. We'll say B is 10. We can say C is, for example, 5, and we can say D is 2, because D is the most common. If you get a line of it, you only win 2 times your bet. If you get a line of C, you get 5 times your bet. B, 10 times, A, 20 times. Sorry that I'm going on and on here, but I know a lot of you don't gamble, which is good, so I'm trying to explain to you how the slot machine works. We're looking at lines, and if you get a line of a certain symbol, based on what that symbol is, you win a multiple of your bet. And you can also win multiple lines at the same time. So you could have a line of A's, a line of B's, 2 lines of B's, depending on how big the slot machine is and how many reels and rows there are. Okay, so we have symbols and multipliers. Now we need these defined so that we can start randomly generating the kind of table or really the grid that represents our slot machine. So the way we're going to randomly do this is we're going to generate an array that contains all of these symbols. So it's going to look like this. We're going to have A, a bunch of times. Then we're going to have B, and then B, and then C, and we're gonna have like, 10 Bs, or 7 Bs, sorry, 4 As, 12 Cs, 20 Ds. I'm gonna put those all inside of an array. Then what I'm gonna do is randomly pick an index within this array, and that's gonna be one of the items that I select to display in this column. And I'm gonna select, for example, 3 indices, and those 3 indices are gonna be the symbols that I show in this column. That's really how real slot machines work as well. We have this large kind of collection of symbols we could pick from. Obviously, because we have more Ds, it's more likely that we'll pick a D, right? We pick random indices, make sure we don't use the same index multiple times, and then display that in the grid. Okay, so you're gonna see when I write the function, but hopefully that's a decent explanation. So what I'm gonna do now is say function, and I'm gonna start by kind of generating this array of symbols so that we can pick from it. So I'm gonna call this generate symbol array. And what this is going to take in is the map of my symbols. Now, since we're taking in a map, we need to define that type. So I'm going to take in a map that has key strings and uint values. Then what we're going to return is we're going to return a slice or an array. I'm going to talk about how this works in a second, of strings. Okay. So in Go, we have different ways to represent arrays. Okay. Now, we have a fixed sized array, which would be this, but actually with a fixed size. So I could say 4 and then string. Now what this represents, this type right here, is the fixed sized array of strings with 4 elements. That means that we have this, like, 1 string, 2 string, 3 string, 4 string. Okay, we have exactly 4 elements inside of the string array. If we change this to size 3, we have exactly 3 elements. And this is fixed size, meaning we cannot change the size of this array. But we have a better, more flexible type in Go, which we pretty much always use instead of that, which is called a slice. Now, a slice is kind of an image of an array. It has an underlying array, so similar to this, like A, B, C, but this array is resizable. Now Go handles resizing it for us automatically, and if I try to add an element to this slice, it will automatically change the size of the underlying array to accommodate the new element coming in. It's a lot more complex than that, but the point is a slice is a more flexible version of a fixed sized array, and it can automatically resize the underlying array for us whenever we try to add an element to it. So the point is we're going to return a slice of string. We're not going to return a fixed sized array, which would be something like, 43 string if we wanted to have 43 elements. So anyways, this is pretty much an array from other languages. That's how you can think of it, at least for now. So now what we want to do is we want to loop through this symbols map, and we want to fill up this array. So I'm going to show you how you iterate over the map. It's similar to how you iterate over an array. And sorry, I'm going to keep calling it an array. Really, it's a slice. Technically, the correct name here is a slice, but excuse me if I call it an array because that's what I'm usually used to. Anyways, what I'm going to do here is I'm going to say for, and I'm going to say that this will be the symbol, comma, count, and then colon equal to the range of symbols. So when you're iterating over a map, what you can do is simply write it like this. I got to type symbols correctly. You say for symbol, comma count, or for the item, comma the value, or the key, comma the value. So this is going to give you the key. This is going to give you the value of all of the entries inside of the map. Okay. So range is used on a lot of different types in Go, but it also works on maps. And in this case, it returns to us the key and the value inside of the mapping. Now what I can do is I can say for, and I'm going to say I colon equals 0, I less than, and this is going to be count, and then I plus plus. Now the reason you saw that we had I and then int count here with the AI, why it was doing that, was because our count here is the type uint. And by default, if I assign I equal to 0, I is going to be type int. So I can either convert my count to an int, so I can do this comparison, because when we do comparisons, they need to be the same type. Or what I can do is I can convert I to be a uint, and I being a uint is fine as well. So I could say I uint 0, and now we don't get that error because we're comparing I to something of the same type. Okay, so keep that in mind in Go. Whenever you do arithmetic or comparisons, you need to have the same type as the left and right side operand, or in this case, when we're doing the condition. Okay, so now we have this loop, and we're saying, okay, we now want to loop through the count. And for the count, what we're going to do is append this symbol into an array. So I'm going to make a new array at the top here, or a new slice. And I'm going to say symbol ARR colon equal to, and then we're going to say string like this. Now this is going to make a new empty slice of a kind of a string array or a string slice. Right now its size is going to be 0, but as I start appending elements to it, it will grow in size. So the way that you append something in Go is you say the name of the array, so symbol ARR, and then you're going to say this is equal to, and then you're going to append. You're going to pass the original array as the first element, and then the second element that you pass here, the second argument, is going to be the element you want to add inside. So I'm saying, okay, I want to append this symbol to this symbol array, and then whatever the result of that is, I'm going to store that inside of this slice. Okay, the reason this works is this append function, if you want to read through the explanation here, will dynamically resize the underlying array that this slice is kind of sitting on top of. And sometimes it may need to return a new array, because if we have a fixed size array, for example, of size 3, and we need to have a fourth element, we actually need to allocate a new array that's now, for example, size 6, add the new element inside of it, and then assign that to this value. I know that's a little bit confusing, especially if you haven't taken a data structures and algorithms course, but pretty much this is how you append an element into a slice in Go, okay? This is the method. It's actually going to return to you a potentially new array or new underlying array. I don't want to get too complex here because, again, slices could take me like 30 minutes to explain all the complexities of them, but this is how you append an element. Okay, so now at this point, what's going to happen is at the end of this function, we're going to have an array or a slice that's going to contain all of the different symbols with their frequency in this slice. I'm trying not to say array. Okay, so we're going to return the symbol ARR. What I want to do now is I just want to print this out so you can see what it looks like before we go any further. So I'm just going to comment out the multipliers here just so that we don't get an issue. And we're going to generate the symbol array and print it out. So I'm going to say symbols or symbol ARR colon equal to generate the symbol array. Why did that not work? Okay, generate symbol array with symbols, and then we're going to say fmt.println. We're going to print the symbol ARR so you can kind of see what we just created. Okay, so let's go up here. If I can bring my terminal open, let's clear and let's run, and you can see that this is what we've created. So now this represents kind of one reel. So what I'm going to do now is I'm going to randomly pluck out different elements from this reel and display those in my kind of slot machine view. Let me just exit out of the terminal here and terminate that. Okay, so now that we have the generate symbol array, I'm going to make that smaller, and we're now going to randomly kind of create that grid. So to do that, we're going to say function, and let's call this maybe get spin or something. And for the spin, we're going to take in the symbols. So we're going to say maybe real is equal to, and this is going to be the array. So we're going to say array of string or slice of string. And then what we're going to return is a two-dimensional slice of string. Now, the reason why I'm returning this is what I want to have is a slice inside of another slice, and each slice will represent a row that I'm going to display to the user. Okay, so we're going to have something like this. We're going to have a slice, and then inside of here, we're going to have 3 slices, each slice being a row, and the values inside of here are going to be the symbols that we want to display. Okay, so now let's start writing this code to kind of generate that spin. All right, so we're going to start by defining the variable that's going to hold our spin, and we're going to say result is colon equal to, and then we're going to say string like this. Now this is how you kind of create an empty version of this slice. Okay, now what we're going to do is we're just going to loop through all of the rows that we have, and we're just going to add an empty row inside of the result. So what I'm actually going to take in is rows as an int and calls as an int, so I can kind of dynamically change the size of my spin if I want it to be bigger or smaller. And I'm going to start by doing the following. I'm going to say for underscore comma, and I'm actually going to go underscore, and then this is going to be colon equal to range of rows, or actually that's not going to work. We're going to say for I colon equals 0, I less than rows, I plus plus, because this isn't a slice, this is just a number. So we're going to do a normal for loop syntax here where we're just looping through like this. And we're going to say result is equal to append result, and then we're just going to append an empty slice. So we're going to say this. Okay, so we're going to create an empty slice of a string, and we're going to add that inside of here. The reason why we're going to do that is we need to have these rows inserted already so that when we start generating the different columns, we can put them in the correct row. You'll see what I mean in a second, but based on how we do the columns, we need to kind of generate column 1, then column 2, then column 3, not row by row. We're generating column by column. So in order for me to add the elements in the correct position, the rows need to already be inserted inside of here, which they weren't by default. So I'm starting by inserting all of the rows. Now that all of the rows are inserted, what I want to do is for every single column, I want to fill up the correct rows. So again, just to make this a little bit more clear, let's say we have A, B, and C. When I generate these, I want to generate one column at a time. So I start by inserting the empty rows, and then for my first column, I'm going to insert in row position 0, and then in the next row at position 0, and then at the next row in position 0, which is what I'm about to do when I bring in these values. So we're now going to say for, and we're going to start with column. We're going to say column equals 0, column less than cols, and then col plus plus. And then we're going to have another for loop, but this time we're going to loop through the row. So we're going to say for row, and then same thing here. Okay, now for my column, what I'm going to do is I'm going to create a map that's going to keep track of the positions I've already selected from my reel. So you see that we have this reel here, right? And what we're really doing is we're selecting unique random elements from the reel to select and put in every single column. So I need to keep track of which ones I've already picked so I don't pick the same position multiple times. So the way that I can do that is like this. I can make a map. So in Go, we don't have the kind of concept of a set. We just have maps, and maps can kind of be treated like a set. So what we can do is say selected colon equal to, and then this is actually going to be a map, and we can say that we're going to have some uint, or let's actually just go with int position that maps to some Boolean. Okay, now this is going to be the index of the position or the symbol that I've selected. I'm going to insert that into the map, so index 2, for example, and then set it to true. So now I can look in the map and I can say, okay, have I already inserted position 2 or inserted position 3 or 4 or whatever I've already selected? And if I have, I can select a different random position. Okay, so we have this selected map, which is really just going to act as our set of positions that we've already chosen. And now what we're going to do is we're going to randomly pick a position. So inside of here, we're going to say for true, and we're going to randomly pick a position in our reel that we haven't already selected for this column. Okay, so the way that we do that is we're going to say random index is colon equal to, and then we're going to call a function that we're going to make here. So I'm going to make a new function, and we're going to call this get random number, and we're going to take in a min and a max, and then return an int. Okay, so inside of here, what we can do is we can say random number is colon equal to, and we can say rand dot and then int n, and then we can say max minus min plus 1 and then plus min. Now what this is going to do is randomly generate a number within the range of our min and maximum. Okay, that's how this works. And then we can return the random number. So what we're doing is we're taking the max, we're subtracting the min, and then we're adding 1 to it. So this will generate, for example, if we had a min of 1 and a max of 10, it will generate some number up to 9 for us. And then we add 1 to this so that we always start at least the minimum. So if this were to generate, for example, 0, we would add 1, and that would give us 1. So the minimum would be 1. I'm not sure how to better explain this, but this is kind of just a random number function we can use. Now, in order for that to work, you do need to import math/rand. This IDE automatically did that for me, but you may need to manually import that yourself. Okay, so now that we have the getRandomNumber function, I can call getRandomNumber, and I want to generate between 0 and what's the number we want to go up to? The len of our symbol array. So this is going to be len of, what is this, real? And then minus 1. Okay, so we want to generate a random index essentially. So we're taking the length, that's how you get the length of a slice, so of our reel, subtracting 1 from that, and then of course the minimum is 0. We're going to store that in random index, and then we're going to check if we've already picked this random index or not. So we don't pick the same element in our reel. So we're going to say underscore, and then exists is colon equal to, and then we can say selected, okay, at the random index. And what this will do is this value here will give us whatever the value is inside of this map. And the exists will tell us if the value exists or not. Okay, so we don't actually care about what the value is, whether it's true or false. We just want to see, does this key that we're checking for actually exist in the map? And that will be given to us in this exists variable, which is how we can treat this like a set. So now I can say if it does not exist, then what we'll do is we'll say selected at random index is equal to true to indicate, okay, we found a unique position now that we want to select. And then we are going to say the result at the index of row, and then at, so row, and then at column is going to be equal to, and then this is going to be the real at the random index. Okay, and then we can break. Then we can go down here and just make sure that we return our result, and that is the function completed. Now I'm going to break it down for you because I understand it's a bit complex. Okay, so we have our reel. This contains all of the different symbols. We have the number of rows and columns that we want to generate. Then we say we're going to return a two-dimensional slice here of strings, which will represent kind of that grid or the spin that the user will see. We start by adding in all of our empty rows to this so that we have those and we can manipulate them later in this part. Then what we do is we start by looping through all of the columns. We loop through all of the columns first because we want to generate column by column, not row by row. Okay, then what we do is we set a set. Now this is really a map, but treat it like a set. This is just going to keep track of random positions that we've already selected from the reel, but notice we define this for every single column. That's because once we finish filling in one column, we then reset this for the next column so we can pick the same positions for the second column or the third column or whatever the next column is that we're generating. Now for every single column, the way that we populate this is by adding in the element in each row. So for every single row, we need to pick one element to insert in that column. Okay, so we loop through all of the rows now, and we go here and we say for true. The reason we say for true is we need to keep generating random indices until we pick one that's unique. So most times this for loop will only run one time, but we just need to make sure we don't pick the same random element twice. Okay, so we say random index, and then we generate a random value that is a valid index. We check if this index already exists in the set of elements that we've selected so far. If it doesn't, that means that we can pick it, so we can put it in the set, and we can then add in the row and in the column the element that we selected, so whatever is actually in this reel at this index. Then we can break, and we can move on to the next element, right? So we go back into the for loop and do this again. Okay, so that gets our spin. So what we can do now, once we have our symbol array, is we can generate a spin. So we can say get spin, and we can say spin is colon equal to this. Okay, and we're going to pass the symbol ARR. All right, now what else do we need to pass? We need to pass the rows and the columns. So I'm just going to pass 3 and 3, indicating that I want 3 rows and 3 columns. But if we wanted more, we could do that. Now I'm just going to print out the spin. I'm not sure actually if this will work because it's a multi-dimensional array, but anyways, let's test this out. So let's go run, and we got an issue here saying index at a range 0 with length 0. So let's see what the issue is there. Okay, so actually the problem is up here. My apologies, guys. I'm saying result at row and then at index column, but we don't yet have any columns. So rather than saying at column, what we actually need to do is we need to say this is equal to append, and then we need to append the result row with this symbol. So I need to actually add the symbol inside because we have just a bunch of empty strings here. Or a bunch of empty slices, sorry, here. So because it's empty, if I try to access index 0, well, nothing exists there, so we get an error. So rather than accessing that, we're just going to append a new element inside of that row, and we'll do that row by row, so we'll end up populating each column one by one. Okay, so the append here is the fix. And let's go now and run this again. Okay, bring up our terminal and go run. And you can see that this is what we get. Okay, so these are our different rows. And if we quit this, so let's close out of it, terminate, and run it again, you should see that we get another random row, and we do. Perfect, that's exactly what we were looking for. Okay, so that looks fine, but obviously we want to print this out a little bit better. So let's make another function that allows us to print out a spin. So let's make this smaller. Let's minimize this one. And let's write our kind of print spin function. So we're going to say func print spin. And we're going to take in our spin, which is going to be this type. And we're not going to return anything. We're just going to print it on the screen. So to print this out is pretty straightforward. We could say for underscore row in range spin. So this is how we can iterate by item when we use the slice here. Then we can say for j comma symbol colon equal to range of row. So now we're iterating through the row, which is a one-dimensional slice. And we can say fmt dot print f, and we can just print out the symbol. And then we can say if j does not equal, and this is going to be the len of row minus 1, then what we're going to do is say fmt dot print, and we're going to print kind of a separator. I'm going to explain this in 1 second. So this should be printf. And then lastly down here, we're going to say fmt dot print ln. Okay. So what's going on here in this print function is I'm saying, okay, I'm going to loop through all of the slices in my spin slice. I'm then going to loop through the row, so all of the row slices. I'm going to get whatever the column is that I'm in, as well as the symbol that's in this row. I'm going to print out the symbol, but only if I'm not in the last column am I going to print this separator. The reason why I'm doing this check is to make sure that I don't print this at the end. So I don't have like, A, separator, B, separator, C, and then separator, because we don't have anything coming after C. So that's why I'm checking this here. And then after we print out one of our rows, I'm going to print a new line so that we go down to the next line and then print the next row. So let's try using the print spin function. So rather than fmt, we're going to say print spin. And now let's go to our terminal and let's run this. And you see that we get our spin. Okay, sweet. So that's that. Now I want to set this up so that we can kind of keep spinning continually and just make sure it works. And then what we're going to do is we're going to write the code to check if we win and manipulate our balance. So we're in the home stretch here. Okay, so we're going to go to our main function here, and we're going to take this spin logic and we're going to move this down. Okay, so we have for balance greater than 0. And we're going to subtract the balance from the bet. And then, of course, well, if they bet, we now need to spin. So after they do this, we're going to spin. We're going to print the spin. And then here, we're going to check if they win and update the balance. Okay, but for now, I just want to run this and just spin it a few times. So let's go here to our terminal. Okay, bring this up. Run the code. Enter our name, Tim. Okay, let's do 23. Okay, we spin, let's do 22. Okay, we spin 24, 45, 76. You see we're kind of getting random values here. 323 is too big, so let's go $11. And then it says we left with 0 because, well, we didn't win and now we have no money left. Great, and you saw here we actually had a line of C's, so in this case we would have won. And if you go through here, you can see sometimes we're getting lines, and obviously you can just mess with the values here if you want to change the probability. Okay, so now we need to check if the user won. This is actually pretty straightforward. And to do that, we're just going to write a function called check win. So we're going to say func, and we're going to say check win. And the first parameter we're going to take here is our spin, which is going to be the string slice, or the two-dimensional string slice. Now, the next thing we're going to take after this is the multipliers. Now, the multipliers is going to be the map of the string to the int. And then what we're going to return is an int slice, okay? Now, the reason why we're going to return an int slice is we're going to return a slice that contains the multiplier that was achieved by every single row. So if we have 3 rows and we won on line 1, for example, I'm going to return maybe 5 if that's the multiplier, and then 0, 0, indicating we won 5 times our bet on the first line. If we won on multiple lines, then I would have multiple multis inside of our returned slice. If we didn't win on any lines, then we would just return 0 like that. and there's no win. Okay. So what we're going to do is loop through our slice now and check if we won. And to check if we won, we just need to look in each row and see if all of the symbols are the same. So we're going to say lines colon equal to, and we're just going to make an int slice like this that we can fill in. We're then going to say for I, comma row, and we're going to go in range spin like this. Okay. Then we're going to loop through each row. So we're going to start by saying win colon equals true. And what we're going to do is essentially look through every symbol. And as soon as a symbol doesn't equal the last symbol that we saw, we're just going to say that the win is equal to false and that we didn't win anything. So we're going to say check symbol is colon equal to row at index 0. Now we're going to assume that we have at least one element in the row, which I think is a fair assumption. And what we're going to do is just check every other symbol and make sure it's equal to the first symbol in the row. Because if any of the symbols are different, that means that we didn't win. Now what we can do is say for underscore symbol colon equals and then range row. And we can just check if the symbol we're currently looking at is equal to this symbol. However, we don't need to check the first symbol in the row because we already looked at it here. So what I can do is I can actually take a slice of this by writing syntax like this. Now I wanted to show you this syntax, but similar to Python, if you've seen this before, we can actually take a slice of a slice, which means when I do this, I'm actually only looking at the kind of second element or the first index until the end of the slice. So this is just kind of cutting off the first element from my row. It's not actually modifying the underlying array, but we're getting now a reference to a new slice that only looks at the kind of first index onwards, okay? Hopefully that makes sense, but if we did something like 1, 3, we'd just be looking at the elements between index 1 up to index 3, but not including it in the row slice. So you can kind of slice a slice, which is what we're doing here. So I'm saying in range row 1 colon, so that I skip row at index 0, which I've already checked here. And I'm going to say if the check symbol does not equal the symbol that we're currently looking at, then I'm going to say win is equal to false. So as soon as we see symbols that don't match, we indicate that win is equal to false, and then we can break. We no longer need to check anything if we found that they were different. Now, if we get all the way down here, so we could say if win, we're going to say lines is equal to append lines, and then we're actually going to apply the multipliers at the check symbol. Now, otherwise, we're going to say lines is equal to append lines and then 0. So pretty much what we're saying here is, okay, if we won, we're going to take whatever the multiplier is for the symbol that we won with and append that into this slice. Otherwise, we're just going to put 0 there because we didn't win with this line. Then we can say return lines like that. Okay, so what we'll do now is we'll go down, we're going to remove the comment from our multipliers, and we're going to start using this. So where it says check win and update balance, we're going to call check win. So I'm going to say winning lines is colon equal to, and then this is going to be check win, and we're going to pass the spin and the multipliers. Okay, now why is that giving me an issue? It's saying cannot use multipliers, type map string uint does not map to string int. Okay, so let's go up here and let's change this to uint type. And now it's giving us an issue with I. So what we can do here, let's just check this quickly, is first of all, I believe that's actually because this is unused. So let's remove unused. And then we have multipliers, check symbol, cannot use type uint as type int. And we can change this to be simply a uint return. And then that should work. Okay, so I'm just matching the types up here. So we just changed the return type and the slice to be uint. So now that when we pass the uint, everything works. Okay, so now we have winning lines. So let's print the winning lines to test that it's working. And then we can handle actually kind of running the winning lines and updating our balance. Okay, so let's save this and let's go here to the terminal and let's run and let's enter our name. Okay, let's bet maybe $10. Okay, and you see that we didn't have any wins, so it's giving us 0, 0, 0. Let's try again. We didn't have any wins, same thing. Let's do 10. Hopefully we're gonna win on 1. And okay, so now we can see that we won. So because we have a line of C's, it gives us 5, so we won 5 times our bet on that line. Let's do 10 again, 10 again, 10 again. You can see now we have another line of C's, so we won. 10 again, 10 again. Okay, we got 2 times our bet, so we won. Okay, we got 2 times our bet here, so we won. Okay, 10 more, and we left with $0. Great. So now we just need to look at these winning lines, and we need to tell the user, okay, you won or you didn't win, and we need to add their winnings back to their balance. So let's do that. We're gonna say for I, comma multi, colon equal to, and then this is gonna be winning lines. What we're gonna do is say the win is equal to, and this is gonna be the multi multiplied by whatever the user bet. We're then gonna say the balance plus equals the win. Now, most of the time, this will just be 0 because the multiplier is 0. But if it's anything else, then we will add the balance accordingly. And then we're going to say if the multi is greater than 0, meaning that they did win, we're going to tell them that they won. So we're going to say fmt.println, and we're going to say, actually, printf. And we're going to say 1 %d with a $sign. And then we're going to do a %d and then x on line number, and then %d, and then \n. Okay, you're gonna see why I did this in a second, but the first thing I'm gonna put is the amount that the user won. Then I'm gonna put the multi that they got, so they can see they won 5x, 4x, 10x, whatever. That's why I did the x. And then I'm gonna put the line that they won on, which is simply I plus 1. So rather than showing line 0, we're gonna say line 1, or line 2, or line 3, right? So that's what we're going to display. Now I believe that's actually gonna complete the entire project. So let's test this out, and then I'll show you how we can clean this up and kind of put it in different files. All right, so let's run this again. It says, welcome to Tim's Casino. Let's go name Tim, enter your bet. Let's go $10. Okay, we didn't win anything, so it didn't say anything, and it's just gonna tell us if we win. So we're gonna keep going until we get a win. Okay, nice. So we won on 2 lines. So it says we won $50, 5x on line number 1, because we got a line of C's. And then we got a line of D's, so we won $20 or 2x, and then our balance went up $70. Great. Now let's bet 10 more. Okay. What did we get here? Enter your bet. Nothing. Okay. 10, 10, 10, 10, 10. Let's go crazy with 20. Okay, and boom, we won. Nice. 5x here. Now notice it's obviously very rare to get the lines of A's or B's because there's fewer of those symbols. And that's kind of how the slot machine works, right? That's how they get you to keep playing because you're trying to get those wins. So you can adjust this if you want. I'm actually doing quite well right now, betting $20. And obviously you can adjust the odds. I'm not sure if this slot machine is good or bad. I kind of just randomly pick the values. And here, look, we got a line of A's. We won $400 because we got 20x our bet on line 3. Now I'm going to go 0. I'm going to leave while I'm ahead, which I would suggest all of you do. And that is going to wrap up the project. Now, before you leave the video, let me show you how we make this code cleaner and take some of these functions and put them in different files. So obviously, you probably don't want to write all of this code in one file because it's going to get kind of messy kind of fast. So let's make another Go file, and I'll show you how you can kind of import the code. So I'm going to say utils.go. And inside of the utils, I'm just going to take some of the, for example, like get functions. So, get name and get bet. Let's take these functions and put them inside of our utils file. Now, inside of this file, you need to make sure the package name matches the package name of your main.go file. If it doesn't match, then you're not going to be able to import this code, or at least not in the way that I show you. Okay, so now that we copy the code inside of here, we need to make sure we import FMT, and you need to make sure you change the name of the functions to start with a capital letter. In Go, the export directive is if we have a capital letter for our function, struct, or other types that we can create names. So make sure that you put a capital. So I have get name and get bet. And when I do that, now if I remove them from here, which I believe I did, I can change the function to say with a capital get name and get bet. And you'll see that it's actually going to be imported from utils.go because it's still in the main package. So that's it in terms of moving stuff over. And I'll also just make another file called spin.go. Okay. And for spin.go, we'll take over some of the spin related stuff. So we can go maybe everything other than check win and paste that inside of here. Okay. Now, same thing, make sure that you use capitals here for the names. Okay. So P, and what is this? Generate. Okay, great. Save that. And then we can go back here, and everywhere we use these functions, first let's remove the math import because we don't need that anymore. We can just change these to be capitals, and then this will work. Okay, so I think that's that. There might be an error here. Yes, we need to change this one to say get random number. And if you didn't want to export something, you wanted it to be private, you could just leave it lowercase and then use it just directly within this file. So for example, here, get random number doesn't need to be exported, so I can just leave it as a lowercase, and now it's kind of privated to this file, and I can just use it within inside of here, not anywhere within the package. Okay, now if you want to run the code once you've done this, it is a little bit different. If you go to the terminal, if you just try to run the file again, you're going to get an issue saying that you don't have any of these files defined. So what you actually need to do is you need to run the package itself, which I'm going to show you in a second, or you can run all of these files together. So I can run main.go, spin.go, and utils.go. And now when I do this, it'll work because I'm running all of the different files. However, if you don't want to do that, so close out of here, there's a command that you can run that will create a kind of Go package, or how do you call it, project for you, that then allows you to just directly run the package. So let me show you what that is. So if you type go mod init and then something like maybe casino here, you can give this a name. This is going to create a new Go mod file for you. And now what you can do is you can directly run this Go package. So as long as you have a main function somewhere, you can just type go run and then dot. And when you do that, it'll look here for this Go mod file, and then it will run just this package itself, which is what I'm doing here. Okay, so now we can play the game like we normally did and just go through and have fun at our casino. Okay, so that is it, guys. If you enjoy this and you like this style of teaching, I do actually have an entire software development course that focuses quite a bit on Go. We teach other languages as well, like JavaScript, but Go is in there quite a bit, and I go through a lot more advanced features. It's a really awesome programming language. If you want to learn it, you can check it out from the link in the description. And I have some other free videos on this channel that cover Go as well. If you enjoyed, make sure you leave a like, subscribe to the channel, and I will see you in the next one.